All right, so here we are with the easier trick. So this will start off pretty easy. Good little warm up here. So we have cosine of x is root 3 over 2. That's my little equation. They're starting off very easy. They'll get a bit uglier in time. And they're saying, hey, is x equals pi over 6 not a solution, or is it a solution? Is that an answer? Yeah. These will have more than one answer, a lot usually. They're saying, is that one of the answers? If you put in pi over 6, does it make it true? Well, I don't know. Let's try it. So here in the beginning, number 1, number 2, they just want you to plug in and say yay or nay, yes or no. So what is the cosine of pi over 6 equal? Does it equal root 3 over 2? Mm-hmm. Well, what is pi over 6? Yeah, put in the 180 for pi. So that's 30 degrees. Go to the unit circle. 30 degrees is right there. And so that's over a large amount, up a small. It's over root 3 over 2, up a half. Cosine is x, sine is y. So cosine is, yeah, root 3 over 2. Yes, it is. That value of x makes the equation true. Good so far? So just a plug-in. We didn't even actually find the answer. We just verified that that is an answer. There's other answers to that equation, but that's one of them. All right, so number 1 is just a plug-ins. Okay, what do you think about that one? The equation is cosine of x is sine of 4x. And they're saying, is x equals pi over 3 an answer? Give it a try. Plug in the pi over 3 for x in both spots, and then work out the left side, work out the right side, and see if they're equal. All right, let's try it. So pi over 3, boom, pi over 3, boom. So we get cosine pi over 3. And here we get sine of 4 times pi over 3. The 4 goes to the top, right, because 4 over 1. So what's pi? 180. Stick in the 180. Use your calculator. This will be cosine 60. This will be sine of, I don't know, 240? Yeah. So the question is, does the cosine of 60 equal the sine of 240? So I'm going to go to the, you could be able to do this on part 1. So let's find it. Where's 60? Right here. 60 degrees. So that is over a small amount, up a large. Right? And cosine is x. So this side's a half. Isn't it? Am I going too quick? Not good? Now let's go to 240. Where's 240? Well, 240, this is 270, so 240 is close to 270, only 30 degrees off of 270. So that is what? That's back a small, down a large. Down, root 3 over 2, back a half. See that? And cosine again is x, sine is y. What do they want? Sine. Negative root 3 over 2. No way, they're not equal. No, it's not an answer. Not a solution. Good? Plug them in, find them on the unit circle. I hope you're comfortable with that. Come see me if you're not. Let's move on. Make sure you can do that unit circle thing I just did with finding the angles from small, medium, large, because that's on everything. Come see me, be glad to help. So let's find all the answers, find all solutions. Okay, sine of x is root 3 over 2. So this will be our last problem for today. This will take all 4 of our minutes here. How do we find all? That's the key word. All answers to that. This is where you really need to be comfortable with the unit circle. Even if I gave you the calculator. You guys have a calculator? You could do some stuff, but I bet if you don't know the unit circle, you'll have trouble because the calculator will not give you all the answers no matter what you do to it. It doesn't know all the answers. You have to know the unit circle. What could you do to get one answer on your calculator? Good job. Hit inverse sine. If you hit inverse sine of root 3 over 2, it'll tell you one of the answers. But that won't get you all of them. So that's why I've been pushing, in case you thought I was cruel and mean all along, I really am meaning for your good to make you really use the unit circle thing in those part ones where there's no calculator. Because I know at this point and then on into pre-calc and calc, you really do need to understand where they're coming from and not just hit buttons, or you won't be able to do the more advanced things, especially inverse functions and trig equations and then some of the things you do in calculus. So now is the time where your comfort with the unit circle will really be advantageous for you. So remember what's going on here. You really need it in this section. Think about the 3 dots in every quadrant. There's 3 dots in every quadrant, right? All right. And I want to know where at those 3 dots is the sine root 3 over 2. And that's the large value, isn't it? The small, medium, large, that's the large value. Sine. So here's what you want to think. Is sine how far over or how far up? Up. Sine is y values, right? Everybody good with that? Cosine is always x. Sine is always y. So they're saying, where is there a y value? Among these 12 dots, 3 dots, 3 dots, 3 dots, 3 dots, which of those 12 dots have y values that are large? That's what they're saying. Do you see that? Because root 3 over 2 is the large. So look at those 12 dots. Let's go one by one. Let's say, okay, how about this guy? Does he have a real high y value? No, he's got a real short one. How about this guy? No, he's medium. I don't even need to think. He's just medium everything. How about this guy? Does he have a high y value? Yeah. There's one winner. He's got he's high up. He's got a high y value. Okay, how about this? Keep going around the circle. How about this guy? Has he got a high y value? Yeah, he's another one. How about this guy? No, he's medium, everything, forget him. How about this guy? Has he got a high y value? No, he's got a low y value. He's only up a half, isn't he? How about this guy? Well, no, now we're negative. I don't need any of these 6. They're all negative y values, aren't they? You with me? This is a positive. So it's this spot and this spot, isn't it? Those are the 2 dots that have high positive y values, large y values. So what are those angles? Well, you know, this is 90 here. This is 30 off of that. This must be 60. This must be 120, huh? Just 30, bump 30 off of 90 in both ways. 120 and 60. Now, your calculator gave you the 60, right? If you hit the inverse button, I don't know if anybody did. It'll only give you the 60. It won't give you the other one. So the answers are really 60 or 120. They're both answers. But we're not done. First off, they want us to turn those into radians. You know how to do that, right? Multiply by pi over 180 times pi over 180. And 60 goes into 180 3 times, so that's pi over 3. This one, how do you reduce this one? I would divide by 60 on both of them. Leave 2/3, so 2 pi over 3. Good so far. Those are 2 pi. This location is pi over 3, and this location is 2 pi over 3. But that's not all. You think, wait, that's all, right? That's all of them within one circle. But they want all. They meaning like you could go 360 and more and hit this spot again. So in other words, you just throw in plus 2 pi n, or 2 n pi is how they usually do it, whatever. Whichever way you want to do it, doesn't matter. 2 n pi. What you're saying is plus any full rotations, there is the final answer. What was that last part? It was pi over 3 plus any full rotations, right? This, and where n is any integer. Sorry, we're running out of time. We'll do more of this next time. This just means full rotations. Like, notice you can go here, or a full circle here, or another full circle, another full circle. That's what we're saying, as many full circles as you want. So that's the complete answer. All right, we'll do more of it next time. That was a good, glad we